In this section, we're going to talk about working with exponents. The expressions we're going to look at are going to be of the form 5 squared, or x to the third, or 7 to the n. In this case, each of these numbers, the 5, the x, and the 7, these are all bases. 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 Each one is a base. The numbers up and to the right, here, here, and here, these are all called exponents. The first thing you need to be able to do is multiply exponents. And the simple rule that we're going to work with is if you multiply two exponents with the same base, you add the exponents, the powers. That's another way to say it too, the powers. So in this case, if you had a squared times a to the third, those two exponential expressions have the same base. They both have the base of a. A squared means a times a, and 3 cubed, a cubed, means a times a times a. There's 5 of them. That's a to the 5th, which is a to the 2 plus 3. So if you have the same base and you multiply, you add the powers. If you have the power of a power, right here, that's the power of a power. You're taking an exponent of something that's already being raised to a power. In this case, it's a squared to the third. A squared to the third. You're multiplying a squared times itself 3 times. Each of those squared is a times itself, so it's 6 of them. It's a to the 6th, which is a to the 2 times 3. So power of a power, you multiply the powers. Here's what these rules look like. Let a and b be numbers, and let m and n be positive integers. Positive integers, that's important. We're only doing powers that are positive integers right now. To multiply powers having the same base, you add the exponent, so 2 plus 7 is 9. To find the power of a power, you multiply the exponents. So 5 squared to the 4th is 5 to the 2 times 4, which is 8. To find the power of a product, find the power of each factor and multiply. So for example, if you have a times b to the m, that's a to the m times b to the m. The power gets multiplied in as long as you're multiplying right here, a times b. So for example, 2 times 3 to the 6th is 2 to the 6th times 3 to the 6th. You have to raise both things inside to that power. And keep in mind, it has to be multiplication in there. It has to be multiplication for this to work. So let's do some examples. 5 to the 3rd times 5 to the 6th. It has the same base, 5. So you add these two, and you end up with 5 to the 9th. You don't really have to do that out. That's a huge number. Keep it as 5 to the 9th. What about x squared, x to the times x to the 3rd times x to the 4th? Again, it's the same base. So all you have to do is add the powers. 2 plus 3 plus 4. It's going to be 5 plus 4 is x to the 9th. And leave it like that. What about something like this? Simplify 4x squared times y to the 3rd times x to the 5th. The first thing you need to do is you need to work with this 3. Remember, the 4 is being raised to the invisible first power. The y is being raised to the invisible first power. So this 3 exponent gets brought into all 3 terms. So it's going to be 4 to the, I wrote a 3 instead, 4 to the 1 times 3 times x to the 2 times 3, y to the 1 times 3, times x to the 5th. Well, that's going to be 4 to the 3rd times x to the 6th, because 2 times 3 is 6, and y to the 3rd times x to the 5th. We're almost done. What we need to combine are these two terms. Everything's being multiplied together. You can change the order. 4 to the 3rd, x to the 6th, x to the 5th, y to the 3rd. We have the same base there, so we add the powers. So that's going to be 4 to the 3rd, x to the 11th, y to the 3rd. The order you put these terms in isn't super important, but generally speaking, you want to have your numeric coefficient first. So 4 to the 3rd first. Put the number first, and then put your variables in alphabetical order. Alphabetical order just makes it a little easier if you have a whole lot of variables in one place. What about if you have a number raised to the 0 power or to the negative power? One way to get an idea of what's going on here is to fill in this chart and see what happens. If you fill in this chart, this is what you end up with. If you fill this chart in, you'll notice a few things. First of all, anything again, these were from my calculator, and I rounded to 3 decimal places. Anything to the 0 power seems like it's going to be 1. You'll also notice that all these numbers are getting smaller as you go to the right and go down. So it gives you something. You also realize none of them are negative. So raising to a negative power doesn't actually make a number negative. So what does the rule actually say? Let a be a non-zero number, or let n be a positive integer. Again, n is a positive integer. A non-zero number to the 0 power is 1. So anything raised to the 0 power is 1 as long as a is not 0. That's right there. Second, a to the n is the reciprocal of a to the n. So a to the negative n is 1 over a to the n. A to the negative n is 1 over a to the n. That is super important to remember. So what does this mean? 2 to the negative 2, that's going to be 1 over 2 squared, which is 1/4. Negative 2 to the 0 is 1. Just by definition, it's 1. 5 to the negative x is 1 over 5 to the x. And what about this one? 1/3 to the negative 1. Well, that's going to be 1 over 1/3 to the first power. Dividing by a fraction is the same thing as multiplying by the reciprocal. 1 times 3 over 1 is just 3. So that's where the 3 comes from. And then 0 to the negative 3, that's undefined because dividing by 0 is an undefined operation. So let's rewrite these with just positive exponents. Remember that 2 to the negative x just means 1 over 2 to the x, the reciprocal. So you have 5 times 1 over 2 to the x. And you can simplify that to 5 over 2 to the x. Over here, keep in mind that the negative 2 power is only affecting x, and the negative 3 power is only affecting y. So that's going to be 2 times 1 over x squared times 1 over y cubed. Multiply across, and you get 2 over x squared y cubed. Be careful. None of those powers are touching the 2, so the 2 stays on top. And remember, the negative power does not mean a negative answer. So what about if you divide exponents? Well, let's see what happens. 4 to the 5th comes out to be 5 factors, and 4 to the 3rd comes out to 3 factors. Well, what happens there? Well, you know that those cancel, those cancel, those cancel. So you end up with 4 squared, well, 4 times 4, which is 4 to the 5 minus 3. So for all the factors on the bottom, they cancel with the factors on the top, like that, leaving you with just the difference left. So that makes the rule, let a and b be numbers and m be integers. That's pretty standard. A to the m over a to the n, and I don't know why they use letters that are so similar. You subtract a to the m minus n, and remember a can't be 0. So for example, 3 to the 7th over 3 to the 5th is 3 to the 7 minus 5, which is 3 squared. What about power of a quotient? What happens if you have a power outside the fraction? Well, you just distribute it into each of them. It's not really distribution, but it's similar. So a over b to the m is a to the m over b to the m. So 4 over 5 all to the 3rd is 4 to the 3rd over 5 to the 3rd. So let's simplify these two. 6 to the 5th over 6 to the 4th is going to be 6 to the 5 minus 4, which is 6 to the 1, which is just 6. Negative 5 squared over negative 5 squared is negative 5 to the 2 minus 2. 2 minus 2 is 0. And we know that anything that isn't equal to 0 to the 0 power is 1. Another way to think about this is you have the same thing over itself. So that's definitely going to be 1, and that matches. What about these? These are powers of fractions. You distribute the 2 in, so you're going to end up with 2 squared over 3 squared, which is just 4 over 9. This negative sign stays out front, and end up with 3 cubed over y cubed. So that's going to be negative 27 over y cubed. That negative was just along for the ride. It's also because it's an odd power. Keep going here. This is going to equal 7 to the negative 3 over 4 to the negative, 7 to the negative 3, 4 to the negative 3. We're not quite done because we still have negative exponents. Remember, this is 1 over 7 cubed over 1 over 4 cubed. Dividing by a fraction is the same thing as multiplying by a reciprocal, so that's 1 over 7 cubed times 4 cubed over 1. So that's 4 cubed over 7 cubed. And for big numbers like this, you can keep it. I mean, 4 cubed is 64, but do you know what 7 cubed is? You can leave it like that. That's fine. Another quick note is whenever you have a negative exponent like this, you can just flip the inside and make it positive. So that's equal to 4 over 7 to the 3rd. Just as a quick side note, it makes it a little easier. So let's do this last question. Simplify these expressions. They look like they're pretty bad, but they're not. So let's simplify the top first. 2 times 9 is, let's leave it together. It's this group, so it's x squared times x, y times y squared. I haven't done anything other than regroup the top. And then you have 3x, y to the 4th. Can we simplify anything on top? Well, the x's have the same base. 2 times 9 is 18, x cubed, and the y's also have the same base, y and y squared, so y cubed, all over 3x, y to the 4th. Well, 18 over 3 is just going to be equal to 6. And right here, you have x to the first and the bottom, so that's going to be x to the 3 minus 1. And then right here, you're going to y to the 3rd minus 4. You have to subtract. So you end up with 6x squared y to the negative 1. But remember, negative power has to go down to the bottom, so it's going to be 6x squared times 1 over y. So your final answer is going to be 6x squared all over y. Moving on to the next question, 2x over y squared to the 4th. You have to bring this 4 into both the top and the bottom, both the top and the bottom. So that's going to be 2x to the 4th over y squared to the 4th. And now you distribute the 4 in both things. So it's going to be 2 to the 4th, x to the 4th over y to the 2 times 4. So that's going to be 2 to the 4th. You can do that. 2 times 2 is 4, 8, 16x to the 4th over y to the 8th. There's a lot to remember, so you might want to watch this twice. I hope you found this video helpful.